This conference will now be recorded.
All right, so we went over chapters 1 and 2. We're in the RH 134 class. We just talked about how to sign all that up. We're not going to worry about that. If you miss these classes, hey, you got to come every week. All right, so chapter 3 is where we're going to start today. We're going to go through chapter 4. I may need to go through chapter 4 again. Chapter 4 is one about ACLs, and that could be a little daunting. And then it gets in chapter 5 goes into SE Linux. So chapter 4 and 5 are really meat and potatoes, I think, of this in terms of things that can be complicated. Chapter 6 gets into managing storage, then LVM, and then VDO, I think it is right here. So 6, 7, and 8 all run together. I think 6 and 7 you'll be fine. 9, I think it's NFS, if I'm not mistaken. Yep, network attached storage. So these 6, 7, 8, and 9 are 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 things that you're going to use throughout your career in Linux. Um, and the reason why I say that is because if you're dealing with someone who's building something on-prem, they're probably going to use some type of remote storage to attach to the instance, just like you would use remote storage to attach to a Docker container, or local storage to a Docker container, however you want to slice that up. And then chapter 10 gets into controlling the boot process. This is managed network security. It does have some SE Linux involved in that. And then 12 gets into installing Red Hat Linux, and 13 is containers. And then the rest of this is 14 is review. All of this is containers here. So 3 and 4, we're going to run that together. 5, I'm going to do that separately. I would love to get through 6, 7, 8, and 9 all in one sitting. That I don't want to make that a 2 week class. I want to knock that out in a week. And then with 10, controlling the boot process, we can walk through that fairly easily. 11, network security. Yeah, we don't need to spend a lot of time there. We can probably do 10, 11, and 12 together. And then 13, the goal, let's see, this is August. I want to be done with all of this and by the by mid-September, end of September. Because I want to get us into I want us to roll into Ansible, which is the RHCSA, I mean the RHCE class. Once we get done with RHCSA, we'll be rolling to RHCE. Once we get done with RHCE, September, we should be done with RHCE no later than September, October, and then once we hit that, we should be uh, zoning in on our cloud stuff, and I want to finish the year out with a cloud cert. You could pick a cert. I could study with you all on any one of those because I'm in those environments every day, so we can go from there. So AWS is the popular one, Azure, then GCP. So you can pick your poison on that. But we're gonna use Terraform in order to deploy to any of them. So we'll be learning Terraform to deploy to those clouds. So it'll be Terraform and a cloud in order to do that. So we're expecting to hit that. So you should, by the end of this year, you should have 3 certifications. And you can run with those as well too. All right. So system performance, tuning system performance. I spoke on this before. Brandon, Greg, he's an engineer over at Netflix. He has a page on here, a website, where we talk about Linux performance, BPF. So an update to this is the Lisa conference. I spoke at the Lisa conference, largest installation system administration. I think that's what Lisa stood for. They're no longer doing that conference. Up with Usenix, they're combining that um, to roll into the SRE conference. It's going to be a track in there. So largest installation system administration conference. All right. So Lisa 2021, June 1st to the 3rd. Um, you have to go online and check out. You have to join their site in order to see their stuff. Let me look at the conference program here so you can get an idea of what I'm talking about. So lessons learned, ransomware tech, beyond fighter fire and safety matches, growing the DevSecOps pipeline. Um, and they just go in here, disorganizing the SRE organization and so forth and so on. You can check this out. I'll post this link. You can check out this conference. And if you see here, show details. If you see here, I think this um takes it over. Yeah, so they give a little bit more. Here's the presentation and so forth, right? So there it's already on their site. You won't find this on YouTube. I can't post it. That's awesome. Let me see if I can close this chat and then come back in and see. Let me see if I can get it. For whatever reason, I can't post. I can't copy and paste. Every week it happens to me. All right, so let me pull this up. Let me pull this up. I'll drop this in I'll drop this in Slack in the RHCSA group so you all can have it as a reference, as a point of reference. But the reason why I brought that up, this particular conference up, is because with this combination of system performance and performance tuning, this leads all over into the SRE jobs. And we've been talking about this for a while. So you as a sysadmin really will start moving into SRE positions. So you see here, BPF internals, Brandon Gregg again. Was this is all about system performance. They have their lightning talks, and these lightning talks are 5 minutes, 5 minutes long. And they have slides that automatically turn every 15 minutes, so you get a chance to you just do your talk. That's what you're doing. Um, and nobody's stopping it. It's just rolling through, so you got to time yourself. Then they get into computing performance. I talked about this before. High performance computing conference. Let's look that up. Um, when we start talking about this, um, again, we're talking about pretty much all your big tech companies use high performance computing. So when we did a ad job last week and cron jobs and batch jobs and so forth, and you do batch jobs in Kubernetes, but this gets into like, and we're talking about this today, where we niche a process or re-niche a process. We give processes priorities. Hey, D through a process, or she's running a job on a machine, a batch job on a machine, and I'm running a batch job on a machine, and it's competing for resources and so forth. We want to say, oh well, D, do you really need that much processing power right now? No, mine can wait. Go ahead and give X, Y, and Z priority over mine, so you can set the priority on a batch process. So that's what that gets into when we're talking about um, deploying onto here. But high performance computing, super huge industry outside of just system administration. But remember, if you're a sysadmin, you're being a sysadmin for the entire cluster. And what does that look like? How do you be a sysadmin for the entire cluster? How do you ensure that the drives are up? Making sure that you got the read write permissions, make sure you have your attached storage, security, the whole nine, the big picture of it all, right? And you can do this on prem and you can do this in the cloud as well too. All right, so they broke this down into the CentOS stream, what that meant. GitOps, we talked about GitOps before. When we start getting into Kubernetes, infrastructure as code, compliance is code, the whole nine. AppSec fundamentals for modern DevOps, protecting system integrity with trusted platform modules, cybersecurity standards, so forth, and the list goes on. You could kind of go through this. I don't want to spend too much time. I just want to give you an idea of where you can get this information from, and where again, remember, we're building a foundation here. So use this as part of your foundation, your foundational knowledge, and then go from there. Okay. All right, so Brandon Gregg, Linux performance. We spoke on this a little bit about this, but he goes into the sysperf, Linux perf, flame graphs. All these things come into play if you're if you're doing your if you're getting into performance and SRE and sysadmin, and why when I run this particular CUDA driver it fails, or if I run this particular NVIDIA driver it fails. What is it looking for? Is something not built correctly? Do we not have the right modules? So forth and so on. And then here's the one right here where he talks about Linux system performance, and he goes a little bit into it here. 64 slides, but you can see again application request time. You talk about that flame graph, what the CPU time looks like, where an error actually occurred. Doing understanding this right here really gets you into the money. Let's say that. I'm gonna post this inside of RHCSA group too, so it's there. All right. So back to the class. All right, so here, I'm gonna blow this up a little bit. I think it should be big enough for everybody. All right, the goal is improve the system's performance by tuning parameters and adjusting scheduling priority of processes, optimize system performance, prioritize and deprioritize specific processes, niche, release, or some people say nice, re-nice. It's always been said to me it was niece, so niece and then re-niece. Adjust tuning profiles. These two are guided exercises. I really won't go through those guided exercises. I'll kind of touch on them, and then they have a lab for them. Well, I guess I can go through a guided exercise, and then you can do the labs yourselves. But the goal is, I want you to be able to understand the different profiles that you get when you're doing this. Any questions so far? I know I've been talking for a minute. Making sure. What's going on, Leslie? Marina, how you doing? Tara, long time no see.
Oh, hi. Yeah, I've been trying to catch up still.
It's all good. It's all good. All right, tuning the system. Okay, so when we talk about tuning the system, let me see where's my little machine at? Mm-mm. Did I minimize it? No. Oh, it's right there. All right, so here let's clear. Let me make this a little bigger. All right, so when I do a PS minus AUX or AUX, you could do a number of things here, but let's scroll all the way up here. And we start talking about these processes right here. So these are processes that are running on my system now, right? And if you were in previous classes, we talked about what each one of these actually mean. What the PID, the percentage of CPU is eating up, percentage of memory is eating up. I forget what VSZ is, and RSS. So Shini, you should know that. You type that in the comments. You should know that. Stat means other word. What's the status of it? Is it waiting? Is it running? Whatever the start time, the time that it the start, which is the date, the time, and then the actual command that's running. So you can see, they've got some processes running on this machine, right? You can see a SSH to here. You can see something is going on with system D there. Our syslog is running cron D, so forth and so on, right? So we see those processes running. I can run another process on this machine, and then on running that process on machine, it'll get registered, and now I run another process and it gets registered, but I don't want them to compete. So here they start talking about adjusting the system itself for a particular profile, and they want you to enable the installing and enable tuned. So here, let's start here. Configuring static tuning. The tune daemon applies system settings when the service starts or upon selection of a tuning profile. The static tuning configures predefined kernel parameters in the profiles. So basically, it passes parameters to the kernel that applies at runtime. So when this is running, when the process is running, it has a certain parameters that are from that profile that it act as, and we'll get into that in a minute. With the static tuning, kernel parameters are set for the overall performance expectations and not adjusted as activity levels change. So once you set it, that's what it is. If you set it for, and I'll jump down here because they have it right here. If you set it for balanced, if you set it for desktop or throughput or latency, that you're saying is static, that's what it's gonna be. It doesn't move if you change something. If you do something that's memory intensive and you got it set to network latency, it's not going to automatically change. It's just going to be static. It's just going to be what it is. All right. So let's go back up here and look at what the other option is. So now we got dynamic tuning, where the tune daemon monitors system activity and then adjusts the settings depending on the runtime behavior changes. The dynamic tuning is continuously adjusting tuning to fit the current workload. Start with the initial settings declared in the chosen tuning profile. And so there's like, for example, the storage may experience high level use during startup and login, but have minimal activity when the workload consists of using the web browser and email clients. Similarly to CPU and network devices. So basically, it's just going in and back and again, it's changing on the fly. All right, so we're going to install Tune on my machine, and then we're going to enable it. Hopefully, I should be able to do that. I don't think I need to be a part of a repository, but we're about to see. So I'm gonna do it. I'm as root. I sudo to root earlier. Those that weren't on here, let me show you what I did. I just sudo su dash to root, and now I'm gonna do a yum install of tuned D. I'm gonna hit dash Y because I want it to automatically install. Because I'm on Google Cloud, it's going to use Google Cloud resources in order to repos in order to install. It says here it's already installed, so let me do a young repo list to show you what my repos are out there. So here's the repos from, I'm on a GCP instance, and it's just showing you like what repos are available out there for me, right? So Tuned is already installed. Again, I always try to show you information that you can get from your packages that you install. So if you do a yum info tuned, it's going to give you information about the package, right? It's going to tell you that comes from the system repository. It gives you the source RPM. It tells you the repo in which it came out of. It gives you information about the project itself, the description, the URL, and then it gives you how they set up the release, the versions of it, right? So that's good information. Another one, information that you can find out if you could do RPM dash dash QILC or dash QILC, excuse me, dash QILC dash dash files by package, and let's put tuned. I want to see what all did it install and where did it install it at. See, I get a lot more information now. So I see some user lib Python. So I see some Python packages got installed. Let me see. I got some stuff over in Etsy. I got some Etsy stuff, some configuration files. I got a profile mode there, post load profile, active profile. So I got something that I can set. So I see that I got some things that I can set and forget on my own. Oh yeah, resonance, set size, and virtual memory size. Thank you. Let's go down here, scroll a little further. We can see here we got something in var log. We have a log file or directory for tuned. We also see that we got some man pages here and some documentation, right? So I can go to I can go to user share doc tune and get some man pages, and then they got a bash complete command. So if I type tuned and hit double tab, it's telling me I got some bash complete commands that I can get. All right. So I found out a lot of information already about this particular package without even doing anything with the package first. This is just how I operate. I like to see what got installed, where did it install it at, and what is the actual package to. So just to inform if somebody asks you on an interview, like, hey, how do we want to find out about a package? You can say, well, you could do a yum info, and then you can find out the packet, the what that package installed and where it installed it at, and gives you a better idea of like basically what they say how it's going to write to your file system. That's not the word that they use most of the time, but that's what that's the clean version of what I was trying to say. All right, so now we have to enable it. So here it's going to create a sim link to be enabled. So that process is going to be enabled. I'm just going to cut and paste here, just being lazy. Get back to my terminal. Let me clear and then paste. Basically, I'm using system D, which is system CTL, to enable this particular process. So what happens with the dash dash now, what it does is it enables the process and starts it at the same time. So now if I do a system CTL status tuned, you see it's actively running. If I didn't do the dash dash now, if I just enable it, I would have to start it, right? But it's already started for me. Okay. All right. So next thing up, now it says now the tuned application provides profiles divided into two categories: power saving and performance boosting. The performance boosting profiles include low latency, high throughput, virtual machine performance, and virtualization host performance. So let's now look and if we jump down here, let's look and see what's active on our system right now. Oh yeah, I'm not on that. Well, I could go there. Hold on. Let me minimize that. I keep going back to my thing. I can go here and get the same thing. Oh yeah, that's right. That's it. I'm on my machine, not on the SSH terminal. All right, so if I do tuned ADM active, I figure it would be virtual guest because remember, I have this machine out in Google Cloud, so naturally it should be using Google Cloud in order to it should be using virtual guest because I'm in Google Cloud. It's a virtual machine. All right, so that's the current active profile. Here it says you want to see what the list is. So if you don't remember that, this is another thing with commands. You could do tuned, double tab. Okay, yeah, ADM dash help. Right. So now the tune ADM dash help. Okay, I can do a list. I can see what's active. I can switch my profile. I can do profile info. So let's do that. Let's do profile underscore info. And then let's do power save. So it says power save, profile summary optimized for lower power consumption. If I want to do the list, is it dash dash list? Or maybe it's a dash list. It's dash dash list. Um, did I do it wrong? Or is it this list? What did I do wrong?
It's no dash.
It's no dash. That's what I did. Did it not like me? Okay, here it are. It just got the dashes in front. So HPC compute, latency performance, and they give you a description over here. Virtual guest optimized for running KVM guests. So on your Linux boxes that you have, say, um, say through VMware, all right, you could change your profile to a virtual host because you run KVM on your boxes as well too. So and by default, we use this inside of by default we use KVM on AWS, GCP, and uh, Azure. Your question is, how can I implement the concepts of the cert into a real world operations? It depends on the operations. If you are, say, a sysadmin and you need to uh you have control of a computer, and this depends on your setup too. Say you're on-prem. Let's move this to on-prem versus the cloud. Say you're on-prem and you need to deploy 15 users across 30 machines. How are you going to deploy 15 users across 30 machines? You can write a bash script to do that, or you can use an Ansible playbook, or you can use Puppet or Chef to do that. But now it's like, okay, how do I deploy 15 users on a machine? Well, first thing you do is you're using user add in order to do that. But again, you got to remember you're deploying across 15 machines. The caveat here is how the question should be is, am I going to be using, is each individual user going to be logging into those 15 machines, and how do we manage those accounts? Or we're going to use something like Active Directory or TripSD in order to manage those accounts, which is a Kerbos based management for Active Directory, really. So those are the things that you have to get into, and when you want to start looking at, you're saying, how do I apply stuff to real world? The more the question is, it's not how do you apply to the real world, it's when do you apply to the real world, right? So that's the scenario. You have to look at what's being asked of you, and then you say, okay, out of my toolbox, what do I need to grab out of my toolbox in order to apply? That's where you start at. As far as downloading Red Hat, you go to redhat.com and you can sign up for a developer's license and download Red Hat for free. If you want to use the environment they already have inside of this particular course, it's probably easier. If you just want to get familiar with playing around with Linux commands, that my best bet to you would be just grab a free account from AWS, GCP, or Azure, spin up a Red Hat box, and then just start playing with Red Hat there. Yep, that's perfectly fine. But that's why I'm explaining it to you this way. I'm explaining it to you from the perspective of being able to say, here's the problem. And I tell everyone in all my classes, you have to be the solution when you walk in the door. Here's the problem. Out of my toolbox, what can I grab that's going to give me uh, this customer the best solution for this problem? And that best solution may be something really simple, because you have to also think about, you're the person that's walking in being the solution, and the skill sets and the things that you may bring to the table, the rest of the team may not have. So you have to look at it from the perspective of, I may have to train everybody else on how to do this. What can I use? What can I grab out of here that's gonna give me some leeway to train people up real quickly? Or I'm gonna be that solution. I'm gonna be that person, and then they only hired me for this particular position. I'm gonna write my notes. I'm gonna drop my journal in here, and then I'm leaving. Like, you're just in and you're out. It depends on how you're looking at yourself. As you can see here, HPC Compute, they got stuff for Intel Select, base frequency, latency, network, and so forth. All right. So that's what they were going through here with understanding, like, how to switch. I mean, not how to switch, but what are your options are, what's currently active. And now we can switch to throughput performance, right? So let's look at what is throughput performance, right? Let's give a definition of that. What are our options to give us a definition of that? So if we go clear and we do tuned dash dash tune dash ADM dash dash help. I want to get info about um some stuff. So let's do tuned dash ADM and then profile info. And I'm gonna just scroll up here because I can. And I want to look at what is throughput performance, broadly applicable tuning that provides excellent performance across a variety of common server workloads. Okay, let's see if they give us any more information when we do this. Maybe the same thing. Oh, that's nice. They copied the wrong stuff. Throughput right here. And back up. Come on, you do it quickly. Yep. So it gives you the same thing. So if you do this to dash dash help, it's going to give you the same profile summary. So you don't, for this particular one, it's just going to give you the same profile summary. All right. So let's clear that. And now they say, let's change that profile. So now if I just go here and do profile info, I'm going to get rid of that profile info, right? And just hit profile. You see that little, did you see that little delay? Now if I go do tuned ADM active, it should have switched over from virtual guest to throughput performance because it was virtual guest before. If I want to go back to virtual guest, I can come here and do, remember this is static. I'm doing this as static virtual guest. Oh, okay, I got to remember what it is. Let's look and see what it is here. Virtual dash guest, not underscore. All right. And now if I go back and do active, right? So remember when you're setting it at the command line, like how I've been doing it, these profiles are static. And remember, if you go back up here, you have power saving profiles, performance boosting profiles, but you also have static tuning and dynamic tuning, right? So you have to remember, static and dynamic tuning, and then the different profiles that you want to go under. So we've been doing static now, right? So now it says tune ADM command can recommend a tuning profile for the system. This mechanism is used to determine the default of the profile system after installation. So like recommend. So let's do that command and let's do a dash dash help on that. Tuned ADM recommend. Let's just do dash dash help. And let's see what recommend falls at. Do they have that in here? Nope. Let's do a man page on tuned. Well, hold on. Let's do tuned ADM. All right. And let's look up recommend. Okay, recommend is a profile suitable for your system. Currently, only static detection is implemented. It decides according to what's in /etc system release CPE, right? So you recommend off of what? Like you need to look up and say what is it recommending off of. So let's go check that out. Let's see what we get there. All right, so here it's saying it's generally available. It's 8.4. It's Enterprise Linux. It's Red Hat, and then it's CPE. But let's go back to this tune profile and let's go back up here to recommend. And in the class, in this class that you have in here, they're not going into detail like this. I'm just going into a little bit more detail to get you to start asking questions why and pushing the needle forward of why would you do something, how to do something, right? So it says in here, the rules for the auto detection are defined in userlib tuned recommend.d 50 tune.com. The default rules recommend profiles targeted to the best performance or a balanced profile if unsure. So let's go one step further and check out this file here. All right, so tune rules for recommended profile. So they got, I guess you could probably come in here and edit this particular one, this particular file. Let me see. Yeah, atomic host. So see, it automatically recognizes atomic host, virtual gas balance, so forth. All right, so it will probably recommend. I wonder if the stars. Let me see. How do you know what's the default? Let's run the recommend. Let's see what happens. Auto tune. Tuned ADM recommend. They recommend virtual gas. Okay, so let's go back to that file. I want to do I wonder, does this star dot plus automatically make it the default? Let's look and see if we have default in here. The word default. Nope, no default. I want to know what automatically makes it pick that as the default. So let's go back to tuned man page and let's look up recommend. Oops. All right, it says in the Etsy. See, the default rules can be overwritten by using a file name called recommend.conf into the Etsy tune, or by creating a recommend.d directory of the file, blah blah blah. Woo, woo. But how do you know that this is the one you want? They don't give me that information. They'll be curious to find out. Uh, Even though you recommend me using that, what are you basing that off of? Are you basing it off of some type of uh, parameter or something like that? I'll look into that. All right, so in here they're going on. See, the output is based on various system characteristics, whether including whether the system is a virtual machine or predefined category selected during the system installation. So it's something that happens during the system installation that it's looking at. To revert the settings made by the current profile, either switch to another profile or deactivate tune, turn off tuning activity with tune ADM off. You can turn it off and then there'd be no current profile, and then tuned active nothing. So then you can enable that. So then this is if you have, which I don't have installed here, Cockpit, and they walk through about how you can check your system via Cockpit. That's what they do here for that. Any questions so far? All right. So in the lab, they go through your lab. Again, you have to come up here, go in here into the lab environment, create the lab, right? Once you create the lab, then you'll say lab tuning profile start, and then you can SSH to the machines, and they walk you through everything we just did. You know, getting familiar with the command line, and then you're finished. So then in the next one, they talk about process scheduling. All right, so this is where we start talking about niece and reniece. If you have not read this is going to be um I guess my thing to you. Read this 3 times, just so you have it. So Linux processes scheduling and multitasking. Again, CPUs can only execute a single instruction at any instance of time to high performing supercomputers with hundreds of CPUs each, and and dozens and even hundreds of processing cores on each CPU, right? Then they talk about relative priorities. So different processes have different run level, well, not run levels, but different importance levels. So the process scheduler can be configured to use different scheduling policies for different processes. The scheduling policy used for most processes regular running on a regular system is schedule other, or in this other case, it's called Sketch Normal, but other policies are exist as well. And so they talk about the different levels right in here. I think they go from 0 to 20 on the positive side. So niche levels values range from highest priority, a -20, to uh to 19. Just some food for thought here. Nice value of processes which are organized at 40 different levels of niceness for any process. That we did. We provided that already. It is we sent you the Slack link, and we also provided the link to the documentation. I'm not sure when you joined, but that's been posted. You all may want to post that again. So by default, they inherit their nice level from the parent process. Remember we did before we did I see PS tree. Can I do that? Yeah, I see Yum search PS tree. Was it PS tree? Let me look it up real quick. I think it was PS tree. Let me look it up. PS tree Linux. Yeah, yeah. Let me see. Make sure I'm using it right. Yeah, I should be able to type in PS tree. That's what I'm looking at right here. PS and then PS3 in the simplest form without any option. PS3 displays the hierarchical tree of the structure of all running processes. Anyway, you can see here system D and then all the processes that run under that, right? The top root item in the tree is the parent process. So that's the parent. And then in this example, system D is the first process that starts, and then PS3 merges identical branches below, blah blah blah, and they're just trying to show you like the output of these things. And then PS3 minus C disable the merging of the identical branches using the PS3-C. Okay, but that PS3 wouldn't work for me, so let me do a Yum search, and it may be in the Apple. No, it didn't find nothing. That's interesting. What happened to type PS? No PS3. I wonder what package has PS3. Package. Let's see, you do it like this. Red Hat package PS3. It used to be in Real 6. So you can do this in PSMISC. Let's see. Yum search PSMISC. Okay. Yum install that then. Yep, not installed. All right. Let's see what happens after we install this. We always can do rpm-qilc-s files by package. And we can do psmisc. And I just want to see what kind of binaries we get here. Look, ps3. All right, clear. Now if I type ps3, there we go. That's what we wanted. So you can see system D, and then the processes stuff all under that, just like we saw online. Cool. All right. All right. So now, look over here. We say by default it inherits their nice levels from their parent process. So those processes are gonna inherit its levels, its nice levels from system D, nice or nice, whatever. By default, the process is inherited, blah, blah, blah. Okay, which is usually 0. Higher nice levels indicate less priority. The process easily gives up its CPU usage, which lower the nice levels and indicate a higher priority. If there's no contention for resources, for example, remember, contention of resources could be your CPU, it could be your memory, it could be read write to the hard drive, it could be read write to something else, it could be network throughput. Those are resources that your processes could be fighting over, right? Access to a disk or something. For example, when there are fewer active processes than the CPU's core, even processes with high NIS levels still will use all the available CPU. Like you may have a process that run and eat up everything on the system. All right, so here they start getting into setting the NICE levels, reporting the NICE levels, and so forth. And so they talk to you about these levels, right? Low priority, high priority, top priority, and we're gonna get into these because this doesn't make any sense to you until you start playing with it. All right, so here, and that's why I say you probably need to read this 3 times. The PS command displays the process NICE levels. So they're showing you how you can get that information. So let's go here, let's grab that, and let's clear my screen, and let's place that here. And let's do a less. Let's pipe this over to head actually. And let's do the first 10 lines. I'm gonna clear, and I'll do that again. All right, so here you can see I have a K huge page, so process ID of 32. It's giving me the NICE level, the CLS. What do they say CLS stands for here? Did they break that down? No, they don't break down CLS level. I guess I don't know. Top flight security. I'm not sure. I had to look that one up. Let's look and see. CLS Linux. I don't know. Yeah. CLS Linux. Yes. I guess I could have did a man page on that. CLS. Did I not? Oh, I typed that wrong. CLS. CLS is the scheduling of the process. Got it. Here we go. So here, quick look up the class scheduling class of the process, alias CLS. TS schedule other. Remember they talked about that up here, right up here at the top. Right here, that the scheduling policy used for most processes running on a regular system is called schedule other or schedule normal. But here you can see the FF is first in, first out. Schedule R, schedule batch, schedule IO, idle, deadline. So if we go back to our, come on, right there. We got the FF right here is first in, first out. TS, which is sketch, other, and batch. So let's pipe this over to less, and then we'll scroll through and see if we see different stuff for the CLS. And you can see the priorities as well too, right? Minus 20, 0, minus 4, TS, FF. You can see all the 19, 5. You can see everything that's being scheduled, and you can see what class that is falling in as well too, right? And this is just if you did a man on PS, that'll come up as well too. So let me clear this and do a man on PS. And if I do CLS, it's in the documentation for PS. All right, so I didn't have to go online. I could have just did the documentation on a man on PS for that. All right. So now let's go back over here. We were here. All right. So basically, we went through. They sorted it by dash nice. Right. And basically in here, they're saying the PS command lists all the processes, their PIDs, the process name, the NICE level or NICE level, and the scheduling class. That's what this is, CLS, the scheduling class. Sorted in descending order by NICE level. The processes that display TS in the CLS schedule column run under the schedule normal or schedule other scheduling policy. The processes with the dash as their NICE level run under the other scheduling policies and are interpreted at a higher priority by the scheduler. Details of this of additional scheduling policies are beyond the scope of this course. All right, so when they talk about the scheduler, does anybody even know what that is? Anybody familiar with how operating systems work? All right, I'm gonna give you this. I can't post nothing there, but we can read it. We can read together. All right. So if you ever take computer engineering or pick up a book to read about how operating systems work, if you ever want to know about Kubernetes and schedulers and scheduling and processes, this is the meat and potatoes of that, right? So the process scheduling is an essential part of multi-programming operating systems. Such operating systems allow more than one process to be loaded into executable memory at a time, and the loaded process shares the CPU using time multiplexing. And so they talk about process scheduling queues, job queues, ready queue, device queues, and the OS uses different policies to manage each one. We just saw this first in, first out for the scheduler when we were talking about the policies here. First in, first out. TS is the schedule other or the schedule normal. RR is the round robin. And then they talk about the priority. Then it's like the two-state process module, whether it's running or not running. Then you have different types of schedulers: long term, short term, and medium term, right? And so this just gets into basically you're controlling the processes on the operating system and so forth. So they break this down a little bit more. I'll put this inside of the Slack group so you're aware of it. It would be a good read because somebody will, trust me, will ask you on a on a on a Red Hat system or in a Kubernetes cluster, what does the scheduler do? What's the purpose and the significance of the scheduler? What is the significance of the scheduler in the operating system? What role does it play? So now you have that idea, all right? All right, so now here they actually are running this command and they're pushing it to dev zero and they're running in the background. And then what they're doing here is they're capturing this process, which is 3480. That's the process that ran. And now they're gonna say, well, give me, let's look up ps-o and then PID CO the command and then the priority level for that when it runs, and they're giving the output of 0. So let's grab that. So we'll grab that and we can play with other commands, right? So in our case it's 7403030. If we use our up arrow here and come back in here, and we could probably search for, was it 34? Oh no, 1348080. That's the other one. Control C. Let me grab that. Let me see. PS. And then 74030. Okay, yeah. So see, it's running in the background. I think I had to pass the dash V, right? Oh no, it's not a dash V. I forget what it is. So I don't repeat the number, the grep here. But you can see that it's running in the background. You can also the R is for the running, the time, and so forth. But now we can pass this command, but let's go up here and pass um this command here. Let's grab this and let's clear let's use our up arrow and pass this in. Okay, so I didn't like that. What we miss? I got to do AXU. Okay, let's go and do AXO. Sorry. Okay, there we go. So basically what I did was I got the PID. I grepped for the PID anyway. I got the PID, the command, the nice level, and then the scheduling, right? And so what they did in their one, they just said output the PID, the command, the nice level for that particular process, 3480, right? So the -O, let's go look up the -O. And we can do -O here. Print only the PID of 42 -O command. Let me make sure -O is just output identical to O. You specify the user defined format identical to -O. -O is the format. So this is the format. Okay. So we're saying in this command here, they're saying put it out in this particular format. In our case, we're going to change that number to 74030, and it's going to put it into the PID, the command, and then the level, the nice level that it's running in. But it didn't give us the TS, it didn't give us the CLS. So on the schedule, is this like an event coordinator? Basically, traffic cop. Who can run what when? And then you can even break it down to like I only want this process to be scheduled to run on this CPU and on this memory. You can even get into that, but that gets out of the scope of the class. But you can do that especially when you start doing HPC, high performance computing. And so we still have this process running though, right? It's still running in the background. So let's it's in the background. Is it in the background? Yeah. So let's foreground that. FG, right? You can control Z to suspend it, and then you can see. I can put it back in the background with BG1, right? And then if you want to kill it, you can just kill it. Kill all. Let me see what I don't even know what it is anymore. Hold on. What is it now? Well, I guess I can run my little command here. Is it it? Yep. All right, so now I can do a kill. Oops. Kill -9 on 74030. And now when I run my up command, it's been killed. All right. All right, so now they said use the -N option to apply user defined nice level to start the process running. So I'm gonna tell it what level right before. By default, it's taking 0. I can do a PKO -9. Yep, I just did a kill -9. All right, the -N option is apply a user defined nice level to start running. The default is to add 10 to the process current nice level. The following example starts a command in the background with a user defined nice level and displays the process. So here, basically -N, give it the run level, and then run this in the background. Then output that command, output in this format, the PID, the command, the nice level, and then it gives you, you're passing the PID. So in our case, that PID number is going to be different. All right. And now we're going to do what they did before. Let me move this up. Basically, you're going to choose my up arrow here and then type in 74105. Oh, oh yeah, it stopped. 74105 right here. See, it stopped. Let's see. Let's double verify that. No, it's still running. I don't know why it showed stop right there, but it still needs to be killed. And I'll use your P kill 74105. And if you go back now and check this out, see, did it die? I'm not showing killed. Let's use my kill -9 because I'm not showing that killed. Now that killed. That killed it. All right. It says underprivileged users may only increase the nice level from its current value to a maximum of 19. Once increased, unprivileged users cannot reduce the value to return to the previous nice level. The root user may reduce the nice level from a current level to a minimum of -20. Right? Yeah, kill -L. There you go. That just gives you a list of the kills. All right. So here you can run at a level and then you can renice, right? Renice, however you want to say it. A nice level of an existing process can be changed using renice. This example uses the PID identifier from the previous example to change to another level. So we went to a 15, and now we're gonna move back to a 9. So let's run it again. Where is my little? Here we go. All right, 7. Oh, that's not what I want. Well, that works because it's running at a 0 right now. So if we do this 74117, right? It's running at 0. So now we're gonna renice this to a 19, and then we'll do 74117. Old priority of 0, new priority at 19, right? And then it says the top command can also be used to change the nice levels as well too. You just have to interface with it and find the PID and then change the priority. But this is probably easier than running the top command, but you could do that inside the top command. And then next they go into the guided exercise for scheduling this, like like what we just did. They actually set you up into a for loop, and they're running this command over and over again. So you kick out 4 processes or 4 jobs, like say batch jobs. And then once you use these batch jobs, then you get you get to see like how much memory they're eating up, the start time, so forth and so on. And then they have you do a P kill on this. That's when you want to use the P kill because you want to kill the parent. I only ran 1, so that's and then they do a P kill on it, and then you check the jobs. And then they go back in, they have you run it all over again, and now you're going to change the run levels on a particular process here. So um, priority, I should say, not run level, priority on that. And then you got to output in that format. And then they give you the command to run, so forth, output, renice, kill, and then exit. And then they walk you through a lab. It says change the tuning profile on server B to balanced, a non-general specialized tuning profile. So I think that would be tuned -ADM profile balanced. Let's see. Yep, tune ADM profile balanced. Yep. All right. So then the next one, 2 processes on the server are consuming a high percentage of the CPU. Adjust each process nice level to 10 to allow more CPU time for the other processes. So again, you find out what the priority or the level it is, and then re-nice that process, like we did here. Re-nice whatever the level you want it to dash in 10, and then the process ID. And they walk you through on, how to sort through and find out what's, getting all your CPU, right? And then you're gonna print that out, and then you're gonna re-nice those two processes, and then go from there. That's what they want you to do. I want to substitute Rocky Linux because we're using Red Hat Linux, and you don't have to substitute anything because the environment is already set up for you. So if you went to lab and then hit create, it's going to start creating the actual environment for you. So you don't have to do anything but really use what they already have. They give you a login to set up everything. So here's the Bastion host, the classroom, server A, server B, the utility, and the workstation. They have the console here already for you. They tell you how long it's going to stop. It's going to stop in an hour. You can increase that. You can have it auto destroy in 7 days, or you can increase the time. Everything is already set up for you. So it's really no need for you to use anything else outside of it, because what happens is inside of the course they're going to tell you to run lab tuning review start, so it's going to go out to the machines and set up the lab for you. So there's going to be certain processes already running. There's going to be certain things already installed for you in that environment. Once you do that, that script is going to run and set up everything for you, and then it'll check your work too. All right. So no, really, like here, lab tuning review grade. If you put this on your individual machine, you would have to find, you would have to say, okay, what is lab tuning grade? You would have to get the script that points to, you would have to either write the script or find the script and put it on your machine in order to do that particular work. So yeah, it's just easier just to use what they already have for this. And you can see it's building. It's active on the classroom. So if I just hit open console, um, whenever that decides to open up, yeah, it's got to take some time there. All right, so it'll open up into a console, which drops you into a shell. It's all shell driven. It's not like GUI driven. It's all shell driven. So that's why I teach from the shell anyway. So you could get used to that. And that was uh 3 and 4. Did I do? No, that's 3. I didn't do 4. Oh, how much time I got to do 4? 10 minutes. We're gonna have to come back next week for 4. Maybe I knock out 4 and 5 next week because they run together anyway. Because 4 preps you right into ACLs. So remember before when we were talking about how to look whether or not we got different or different set UID, GUID set on a file. This gets more into what that actually looks like when you're setting it up, and they get into get FACL, set FACL, all these things here. Now we need to spend some time on that. I'm not gonna be able to knock this out in 10 minutes, but this is gonna be fun. I advise you go over this 3 times as well too, because this is gonna be this will be in an interview and on an exam. And as you can see here, they have like how to use these things. The other piece that I will look at is Fedora Documentation, ACLs. All right, so they have a good setting access ACLs. They break it down a little better. I think their documentation is a little better to me, just as another reference. How to set it up on a directory, how do you retrieve, what does each one mean. I would use their documentation in order to look at that. Their security guide is probably pretty good as well too. This is older. You can come up here to 26. see, sysadmin guide. And then you can go to security guide. It still takes you back to 14, but if you look down here, what is SE Linux? Defining assessment and testing, network security, verifying signed packages, the bootloader, port map, single sign-on, PAM modules. All this falls under the security stuff, which is very good how they've got this set up. So you could really get into the security side of 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 an operating system. The other one that I think you'll find is a deployment guide. And we can drop down here where they start talking about RPM, network configuration, what is a DHCP server, how does DHCP work, SSD, all these things are foundational knowledge that they kind of hint on it in the RHCSA, but they don't really get into it. Like we did the cron jobs, automated tasking, and so forth. They get a little bit more into it, give you a little bit more detail than what you get out of the RHCSA class. You get enough out of the RHCSA class to pass, but if you wanted to dive and do a little bit more, this is the actual documentation that I turn to when it comes to. I think Fedora does a great job of documentation, more so than what Red Hat does, depending on what it is in Red Hat. And then if you hit the guide, system administrator guide, again, LVM, partitions, file system structure, EXT3, that's older, EXT4, we're on XFS, what is NFS, file system caching, encrypted file system, swap space, disk quotas, input output storage, a remote diskless systems. You can do diskless clients where you don't have a disk. All they do is just boot up off the network and they just serve up. They hit the DHCP server, it hits a profile, it serves up that profile to that system, and you can log in and play with it, and it can be a diskless systems. That's a really, really good exercise to try if someone wants to in their own little environment. You could probably do that on a couple of Raspberry Pis. Fiber channel, iSCSI storage, old school. Excuse me, device mapper, old school, always needed. All this is always comes up. Like, hey, I attached a SAN storage to a HP 7000 blade chassis, and now I need to partition that blade storage out. When I talk about HP blade chassis, I'm talking about this. This is the old one, the BC 7000. This is the old one. So back in the day, you have half height, full height. These are half height blades. Also, but a full height will be this entire section here. And on that blade, you can get your fiber storage. You can get your 4 or 8 core machine, 64 cores if you want to. Takes up a lot of space. But you can see you got your SATA drives right here on it. You can set them up in a RAID 1 or a RAID 0, depending on what you need to do with them. And then you attach your fiber storage from there. But the HP blade chassis, let me see, do they have newer ones? I'm sure they do. I want to see if they got any. Yeah. Yep. This is their blade chassis. And then you got a blade server itself, right? And then you have like the virtual connects and so forth. So my experience with these, I used to take these out of the box, rack and stack these, attach the storage, attach the power to them, set up the fiber channel, get them all talking using over fiber, and you can have this set up for an entire data center. Or I would manage probably about 10 to 15 of these at a time, depending on the project. And you be all in. You could have 1 terabyte storage, you could have 2 terabyte storage, you could have fast this, slow this, but you really start getting into that when you start talking about your SAN. When you talk about SAN storage, Dell, HP, it don't matter. Now you start getting into things like this. And now I'll show you the back of these as well too. Let me see, do they have a back? Yeah, so see, we start getting into 12 gig mini SAS HD for the SAS cables, 960 for solid state drives, your input, your output, your reads on what you want to have. And then the power that you want to have, the C19, the C20s, you start getting into trying to figure that out. And then on the back of these, you probably fiber connect these up. Then this is all up on a tangent. You start getting into InfiniBand. And now we start getting into, these are the, where we start looking on the back of stuff and start getting into just different things. So, I know that's way over, but hey, that's just something that you need to be aware of. I'm gonna stop recording as well too.